marker with me here. I mean my calculator. In the pocket is better. No, I will not use it. I'll just simple calculation. So welcome back from the short break again. We have just been looking at relative atomic masses, and we have seen how to get the relative atomic mass, of which they will not ask you to derive. They will simply give you the values of the relative atomic masses, either on the first page of your question paper or against each question. If they see that what they could have given you, that side is not part of what you are supposed to use. So let us look at something else now, which we are going to use, in this case from the relative atomic mass, that is relative formula mass, which is always denoted by R, F, M, or it is RFM. It is also sometimes referred to as relative molecular mass, which is R, M, M, or M, R, relative molecular mass. Now, much as they may refer to almost the same thing, but there's a very simple difference here, that relative formula mass pertains to mostly ionic compounds, and relative molecular mass pertains to mostly covalent compounds. So, this one now does not deal with atoms, but it deals with compounds which is containing a number of atoms joined together or bonded together. So let us try to see how we can also get what we call the relative formula mass. In fact, the relative formula mass, in simple terms, it is the mass of 1 mole, not of atom this time, of 1 mole of a compound. We divide it by 1/12, that is 1/12 of the mass of 1 mole of a carbon or of carbon-12 atoms. So, relative formula mass, which is also relative molecular mass, if it is a covalent compound, it is a ratio of the mass of 1 mole of a compound to 1/12 of the mass of 1 mole of carbon-12 atoms. So, the most important thing right now here is to get how to get the mass of 1 mole of a compound. Then we shall see how we can substitute for that, and then we get the relative formula mass. If I have a compound like, say, carbon dioxide, we are going to look at how to get the mass of 1 mole of that compound, carbon dioxide. So what we firstly need is to know the chemical formula of carbon dioxide from the valencies of the elements that are found in carbon dioxide. So in carbon dioxide there is carbon and there is oxygen. So the atomic number of carbon is 6, the electronic configuration. So let's start with carbon. Atomic number is 6. The electronic configuration is 2 to 4. So the atomic number in this case is the number of protons, which is the same as the number of electrons. So the electronic configuration is 2 to 4. Now, if I want to get its valency, and the valency of carbon in this case is the combining power of carbon. The valency is got, since it is a non-metal element, I will subtract the number of electrons in the outermost shell from the maximum number of electrons that this shell can carry, that is 8. Or it is the same as also the number of electrons that are required to fill this outermost shell. So the outermost shell is supposed to have a maximum of 8 electrons. So I need 4 more electrons to fill this outermost shell. In other words, I will be subtracting 4 from 8. So 8 minus 4 gives us 4 as being the valency of carbon. We expect a candidate to be knowing how to get the valency of an element. Now let us look at also oxygen. The atomic number of oxygen is 8. So the atomic number is 8. The electronic configuration, let me use EC. Electronic configuration is 2 to 6. So it is also a non-metal element. The valency is just 8 minus 6. And this one gives us a valency of 2. Now, we are going to give carbon its valency of 4. We shall write it here as a power. The valency of oxygen is 2. We shall also indicate it as a power. Now, in the process of combining these atoms here, we shall make them exchange these valencies here to become their base numbers. In this case, the valency of oxygen, which is 2, will become the base number of carbon in this case, and the valency of oxygen, which is, and the valency of carbon, which is 4, will become the base number of oxygen, which is 4 in this case. So you can see that 2 and 4 are multiples of 2. So we shall reduce by 2. If I reduce by 2 here, I will get 1 carbon atom remaining, and oxygen atoms now becomes what? 2. Now this one is obvious, it is automatic, so we shall have 1 carbon atom and then 2 oxygen atoms in carbon dioxide. So the formula of carbon dioxide is this. I expect a candidate at this time to be knowing how to get the formula of a compound using the valencies of the component elements. So for carbon dioxide, remember we are trying to look at the mass of 1 mole of carbon in this case. The mass of 1 mole of carbon dioxide as a compound. So it is the carbon dioxide is CO2. CO2. So we are going to use the relative atomic masses of these elements here. Remember we had said that carbon has got a relative atomic mass of 12 and oxygen has got a relative atomic mass of 16. So there is 1 carbon atom, and 1 carbon atom, one atom of carbon has got a relative atomic mass of 12. So it will be 12, of course, times 1, but that is 12. Then we shall have oxygen atoms, which are 2 here in carbon dioxide. So we shall have 16, which is the relative atomic mass of oxygen. We multiply it by 2. And this one gives us a total of 12 plus 32, which gives us 44. So this is the mass of 1 mole of carbon, 1 mole of carbon dioxide. Now let us look at the relative formula mass of carbon dioxide. Relative formula mass. We shall get it from this very expression that it is the mass of 1 mole of a compound, in this case it is 44. We divide it by 1 over 12, 1/12 of the mass of 1 mole of carbon atoms, which is 12. So this 12 will go with this 12. Remember here there is grams, here there is grams. So we remain with the 44 grams over 1 gram. This gram goes with grams and we shall have what? 44. So this one becomes the relative formula mass of carbon dioxide. You can see from here that even the relative formula mass, just like relative atomic mass, it has got no unit. Relative molecular mass of carbon dioxide is 44 without the unit. Now, it makes us to go ahead and define what we call the relative formula mass of a compound from this expression here. So we can define relative formula mass, which is also the same definition for relative molecular mass, though this one refers to covalent compounds, that it is the ratio of 1 mole of a compound to ratio of the mass of let me insert it here, or let me just put it afresh. It is the ratio of the mass of 1 mole of a compound to 1/12 of the mass of 1 mole of carbon 12 atoms. This is what we call the relative formula mass of a compound. The ratio of the mass of 1 mole of a compound to 1/12 of the mass of 1 mole of carbon 12 atoms. So we shall not ask you to get it from the other expression which we saw, but you will have to calculate what we call the relative formula mass or the relative molecular mass of a compound. So I told you that the prerequisite skill for the calculation or the prerequisite knowledge, which a candidate is supposed to have, in this case is for you to writing the correct formula of a compound